Alright guys, today we are going to be on 10.2. It's the last section of chapter 10. And guess what we're going to be talking about? You got it, 10.1. Just as a reminder, we talked about percentages or proportions. So guess what 10.2 is going to be about? Means. Right? We got that two stuff going on, alright? Proportions and means. So now, flip over in your mind. We're working with mean stuff now. Alright, so let's recall some mean information first of all. First off, sample standard deviation is all over the square root of n. Remember that one? Okay. Normal. What else? How do we know it's normal? It's got to be greater than 30. Right? More samples have to be greater than 30, or the population shape has to be normal as well. Okay. How do we test if it's independent? Well, it's got to be 10% rule. And then what's the other one? Oh, I know there's another one. I can't think of it right now. Anyways, okay. So you should have your notes, 10.2 notes. Make sure you take them out. We're going to get through page 1 and 2 today. So first off. Well, we know, and I'm going to try and zoom through this here. Apologize because I know it's small writing, but you do have the notes right in front of you. Chapter 7, we saw the sampling distribution of a sample mean has the following properties. I already kind of talked about this. Shape. First of all, how do I know it's normal? Well, it's normal if n is greater than or equal to 30. Or it's called the central limit theorem. Very good job, Kim. Well done. Okay. Center. Well, you probably can't see that, but the center is, well, the mean of the population is going to match actually the mean of the samples. Okay, yes, Henry. Do I need to go over that again? Alright, and then the spread, obviously we already talked about standard deviation of our sample is going to be the true standard deviation all over the square root of n. Okay, so here's a question. We're into comparing two different things now. We're seeing if there's any difference, or what is the difference. Okay, what's that little interval between two things? So here's a situation: boys and girls heights, and it's actually 10-year-old boys and 10-year-old girls they measured. And actually, at that point in time, I think girls would probably be peaking a little bit higher than boys. But let's see. It says, based on information from the U.S. National Health and Nutrition Examination Survey, the heights in inches of 10-year-old girls follows a normal distribution. Ooh, you remember what this means? Okay, well it means mean comes first, standard deviation comes second. Remember that. Mean comes first, standard deviation comes second. So for boys, the mean is that, standard deviation, and actually I think these are true means. So let's get that symbol right. So, and over here. Okay, suppose we take an independent sample of 12 girls, 8 boys. What can we say about the difference? Okay? Describe the shape, center, and spread of our samples. Okay, so our sampling distribution. So if we collected 1 billion samples of 12 girls, 12 girls and 8 boys, what would all those samples look like? Okay, what kind of curve? Well, let's see, what's that shape going to look? Well, is it going to be normal? Well, I need them both to be larger than 30. But there's one more, if you guys don't remember. Yeah, there might not be 30, but is the population normal, okay? And it says, the heights of 10-year-old boys follows a normal distribution, and heights of girls follows a normal distribution. So therefore, my sample will be normal because pop is normal. Center. Well, I guess think about my center of these two things. If my center of girls is 56.4, my center of boys is 55.7. I want to know the difference. Remember, I'm comparing between these two things. What's that difference going to be? Well, I'm going to subtract, because that's what subtraction is. And I believe I have a difference of 0.7 inches. So, at age 10, it appears the mean, the middle of where boys and girls are at, it looks like girls, remember, because girls is first, right? Girls are roughly 0.7 inches taller than boys. That's the mean. So shape, center, and then our spread. Okay, and this is where it gets a little groovy. Alright. If you don't remember, if I want to I want to subtract standard deviations. I can't do it. I cannot subtract standard deviations. First off, I have to add and I have to square them. Remember, so if I'm taking my standard deviation of girls, that's a bad initial. Say girls and guys. Okay, if I want to add those standard deviations together, that's going to give me the standard deviation combined of girls and boys. Okay? So that's going to give me squared, so then I would actually naturally have to square root it. So if we're talking girls and boys, okay, we know the standard deviation for girls is 2.7, right? Well, I'm going to have to square root that, and they had 12 girls, right? I know standard deviation for guys is 3.8, and I collected 8 samples of those. Now I can't just add them together, okay, or I can't just subtract them, sorry, because that's where we're finding difference. I have to first of all add them together, but I not only add them together, I have to square them both, right? Okay. Well, what's going to happen if I square that? You're going to get 2.7 squared, if I'm not mistaken. This is going to give me 3.8 squared. What happens if I square square root? Ah, now you're getting it. They drop, right? Square square root, it's just going to be 12. What do you think is going to happen to square a square root of 18, or 8? It's going to be 8. Okay? Finally, what was that last thing I had to do? So not only did I have to square them both, okay, that would combine them, but to finish it all off, to top it off, I have to square root it. So that is going to be our new formula for when I want to combine or find the difference of standard deviations. I'm going to actually want to have a square root of the deviation squared over my number of samples. So slightly different than the originals, right? Remember, originally we would just have this rot right here. Okay? But since we're combining them, it's going to look a little different. Okay, so be careful on that. So you can fill that in on that blank. Alright. So we got the shape, center, and spread. If you do calculate that all out, I believe you get 1.55 inches. Okay, that would be the standard deviation. that it would change between girls' and guys' heights. Okay, remember, because that's the difference. The average difference. Okay. Alright, we're going to skip over a lot of this stuff because it's a lot like percentages. First of all, we already discussed the new rule, and you might want to star that and say, hey, listen, that's how I'm going to do standard deviation when I subtract. But odds are we will not know these. Odds are we will not know them. So therefore we will be using S. And when we have S, there's always somebody that tags along with sample standard deviations, and that is my t-score. Woo! Alright, so no more z-scores. Remember, z-scores only work for percentages and if we know our true population standard deviation. Okay? Moving on, page number 2, flip. Alright, so I'm just going to cover confidence intervals and then we're done for the day. So, confidence intervals. If you remember, confidence interval normally would be my value that I got, plus or minus that margin of error. We kind of talked about this yesterday briefly about the election. But the margin of error is my critical value times, sorry, I'm getting percentages in here. Critical value of this over this, okay, or your standard deviation. Well, now, since we're not dealing with standard deviation, now since we're combining things, we're going to actually have x bar 1 minus x bar 2. So the difference between those two things, my critical value, or my t-score, times then that new standard deviation that we got. Alright, so that's just a new formula. That might be another nice thing to box and star and say, I don't want to forget that. Alright? Same things apply. Random, obviously, we need things random. Normal, it's got to be greater than 30. Both. Not just one. They both have to work. Okay? And then independent, remember, 10% condition. Here we go. Alright, so there's a situation here. Can we solve it? Some trees have been left relatively unscathed for hundreds of years. And this preserve in Georgia is wondering, do the north trees have a larger leaf than the south trees, or vice versa? So they figured out all this nice good stuff, and they said north trees has all that good data, and south trees has all that good data. South red. And then they did a dot plot of north and south. So we're going to do a construct and interpret a 90% confidence interval. So first I'll state, how do we state confidence intervals? Well, we're going to state our parameters of interest are the mean, or the true mean of what they actually call is my DBH. DBH. Okay, diameter at breast height of all trees in the southern half of the forest, and the true DBH of all trees in the northern half of the forest. Okay, we want to estimate the difference at 90% confidence. Now remember, we're no longer going to say, hey listen, you got to do the 4-step process. If you're asked to do something like get a confidence interval or do a significant test with your HO and your HA, you just do it. Do it. Okay? Do a 4-step process. Plan, we should use a 2-sample t interval. First of all, random. We do have 30 in each, right? So even though these might be a little skewed, that looks like it's skewed to the right. This one looks like it's skewed to the left. But even though our samples are more than 30, so we're good, it looks like. For me, I'm sorry, random, obviously. Is it a random? I'm getting ahead of myself. Is it random? Where does it say that? Random samples. Random. Sure thing. Normal. Box plots, like I said, give us reason to believe that the population distribution may not be normal. It looks like it might be skewed a little bit. However, since both samples are at least 30, we are safe to use T procedures. Okay? Independent. Researchers took independent samples, meaning they didn't require or depend on anybody else. Because sampling without replacement. Sorry, replacement. It's really hard to write these little blanks. Was used, there has to be at least 10% rule, remember? Well, we collected 30 samples, so there has to be at least 300. Can we assume there's 300 trees in a forest? I would hope so. So it is safe to assume. Okay. So once again, that's sampling without replacement. If you can't read that. And we're safe to assume. So now we're on to the do. Since the conditions are satisfied, we have satisfied all solutions, we can construct a 2-sample interval with degrees of freedom of 29. Alright, so here we go. First off, the south had an interval. Remember, its mean was 34.53. Okay, we're going to round it. Minus, because I'm checking out the difference between north and south, 23.7. That's basically where my starting point is. Okay, what's that actual difference? Okay. Which, if I'm not mistaken, I believe the difference is 10.83. Then I'm going to go plus or minus. I'm doing two levels here at the same time, simplifying and the correct answer. Plus or minus my t-score. Ooh, my critical value t-score. What is that going to be? Well, by the beauty and magic of television, I have our t-score table here. What did they say again? Degrees of freedom of 29. Degrees of freedom of 29. With a 90% confidence interval. Boom. 1.6. I think that's 99. 1.699. Looks like it's going to be my critical value. So, I am going to put 1.699. And then my standard deviation, which is going to be that big roddy thing that we just talked about. So what's it going to look like? Well, it's going to be standard deviation. Well, the standard deviation of the one before is 14.26 squared all over 30, because I got 30 samples, plus 17.5 squared all over 30. Okay? And I think the rest is history, guys. That was all standard deviations right there. From my south to my north. 30 samples. Bada boom, bada bing. I should get 10.83 plus or minus. Final thing would be, I think, 7. Which gives me a great interval. If I want to actually do an interval, I would say maybe from 3.83, right? Because that's 7 lower than 10.83, to 17.83. Okay, that looks like the actual interval. So 10.83 plus or minus 7, okay, with my margin of error. So, in conclusion, I've gotten a little ahead of myself here. In conclusion, it appears to me, I am 90% sure, because remember that's my confidence value, 90% sure that the true difference, or actually let's say this, southern trees have a DBH that is 3.83 centimeters to 17.83 centimeters different than northern trees. Booyah! Your homework. What I want you to work on is the first part. It's 35A to 39, 43, and 45 BC. Alright, we'll work on the AD stuff later. Alright, this is later half. Don't worry about that now. We will do that. But I want you to get through 45 BC today. Go get them, Cougars. Shivi out.